A matched molecular pair is two compounds that differ by replacement of a small contiguous fragment, for example, a substitution at a single point. This replacement can be thought of as a transformation. Matched pair analysis explores a dataset of compounds with measured data to find which transformations have been made and identify transformations that have a consistent, significant impact on a property. This analysis can identify important transformations that may be applied to guide further compound optimization. To run a matched pair analysis in StarDrop, select Find Matched Pairs from the Tools menu or from the Analyze menu in Card View. By default, each matched pair will be represented by a link in Card View, and you can choose to color these links by the change in a property. In this case, we will explore the potency against 5-HT1A expressed as a pKi. In this dialog box, you can also choose how the results will be displayed, as a table, a network in Card View, or both. We will look at both outputs, which is the default. Clicking OK will run the matched pair analysis. If you have chosen to see the results in a table, a window will appear. The top of this contains a table showing all of the transformations that have been found between matched pairs in the dataset. A count of the number of occurrences of each transformation is shown in a column, and the remaining columns show the average change in property between compounds related by this transformation. You can color these columns to create a heat map and sort by clicking on the column headers. In this case, we can see one example of a transformation that corresponds to removal of a benzylic group. This occurs 4 times and on average results in a 1.5 log unit increase in potency. Selecting this row displays the 4 examples of this transformation in the table below. At the bottom of the window, a histogram shows a distribution of the changes in potency for the 4 examples of this transformation. In Card View, each matched pair is shown as a link between the corresponding cards. These are arranged in a network to show the relationships between compounds. Disconnected sections of the network indicate groups of compounds between which transformations have been explored, but which are not linked to other groups by a simple transformation. In this case, they represent different series or scaffolds. You can see that the transformations selected in the table have been highlighted in the network, so we can see where they have been applied. For the selected transformation, the examples which give rise to large increases in potency occur at similar positions in 2 similar scaffolds. However, the example in which the potency does not increase corresponds to a very different context. By exploring in this way, we can quickly identify the context in which the transformations may apply and learn where structure-activity relationships may be transferred between compounds and series. This example has demonstrated the matched molecular pair analysis tool in StarDrop and its interaction with Card View. This marks the end of the series of hints and tips videos focused on Card View, but you can find many more hints and tips on the Optibrian community at the URL shown below.